हाय माय डियर फ्रेंड्स, कैसे हो सब? बढ़िया एकदम। और पढ़ाई कैसे चल रहा है? ठीक ठाक। सो इन द लास्ट क्लास वी डिस्कस्ड about comparison test and limit comparison test, but it is not a easiest way to know whether my series will be convergent or divergent by comparing with another, because in comparison test or limit comparison test always we have to assume one series. In every problem one series will be given, another series you have to assume only. Yes, फॉर एग्जाम्पल जब हमारा पेरेंट्स कंपेयर कर रहे थे ना, तब उसी टाइम तुमको क्या लग रहा था? अरे वो कंपैरिजन क्यों कर रहे थे, और कुछ नहीं है क्या उनके पास? चलो वो कंपैरिजन आज छोड़ देते हैं. Let's study about ratio test and root test, two more new tests for knowing my series will be convergent, divergent. But remember one thing, it is these tests are not valid for everywhere. It may be fail somewhere. So at that time you again have to go comparison or limit comparison test. Like तब टाइम उसी टाइम में तुमको क्या लग रहा था? वो गलत है, हमारा पेरेंट्स जो कंपेयर कर रहे थे वो गलत है. बट जब ऐसा कुछ 3-4 साल बाद जब नौकरी का टाइम आएगा ना, तब तुम खुद कंपेयर करना स्टार्ट कर दोगे. अरे वो जो क्या है, दीपक अंकल का बेटा का नौकरी हो गया, मेरा नहीं हुआ. तुम खुद कंपेयर करना स्टार्ट करोगे. यस. सो चलो पढ़ते हैं रेशियो टेस्ट और रूट टेस्ट. लेट्स माय सीरीज इज एन. सो रेशियो टेस्ट, रेशियो में समझ में आ रहा है ना, कुछ कोई दोनों का रेशियो निकालना है. बट यहाँ पे एक ही सीरीज है, सो किस दोनों का रेशियो निकालना है? सो आई हैव टू फाइंड लिमिट n टेंड्स टू इंफिनिटी an plus 1 by an. So I have to find this limit. But what I have to find? Root test. Root test. What is the root? Means that's power something 1 by something. Yes. Means an power 1 by n. I have to find this limit. Yes ना? Root. समझ में आ रहा है? So let's check. When it will. Suppose this is coming. Both are coming as L. Suppose here it is coming L. Here also it is coming L. This L may be different for different test, but let's say it is coming any random number L. Okay. And what can be my L? L may be less than 1, may be equal to 1, may be greater than 1. These are the three possible cases. If my L is less than 1, then my series is convergent. If my L is less than 1, my series is convergent. If L is greater than 1, then my series is divergent. Then what will happen if my L equal to 1? If my L equal to 1, my test fail. This test is not valid. वही बोला था ना मैंने. This is not the case that these tests are always valid. This test may fail in some cases. At that case, you have to again go to that comparison and limit comparison test. Okay. So let's consider one example. Suppose my series is n factorial by n to the power n. Okay. First thing, which test will apply? I will apply whether ratio test or root test. Here it is factorial term is there. If I will use this root test, means n factorial power 1 by n, it will be more difficult for me. So what I will apply? I will apply ratio test. So what is my an here? My an is here n from 1 to infinity. My an is n factorial by n to the power n. So in ratio test, what I will check? Limit this one. So limit n tends to infinity an plus 1, means n plus 1 factorial by n plus 1 power n plus 1 into n power n by n factorial. See here my n factorial, n plus 1 cancel, 1 n plus 1 will cancel. So what will remain? Limit n tends to infinity n by n plus 1 whole power n. Yes, if I divide n in both numerator and denominator, what I will get? Limit n tends to infinity 1 plus 1 divided by 1 plus 1 by n whole power n. And what is this value of this limit? This limit value is equal to e. So if you don't remember, just go through the lecture number 8, evaluation of limit. So this will become 1 by e, which is less than 1, because e is a number which is equal to 2.718 something. Na? So it is less than 1. So here, if it is less than 1, then my series is convergent. So this series is convergent. Hopefully it is clear. Let's do one example on root test. Suppose my an is 2 to the power n by n. Means my series is summation of n from 1 to infinity. See here it is 2 power n is there. You can apply also ratio test, but I am showing you by using fruit test. Okay, so check limit n tends to infinity n power 1 by n. 2 to the power n by n power 1 by n. It will become limit n tends to infinity 2 divided by n power 1 by n, and this value equal to 1. Again I am saying just go through the video of evaluation of limit. So this will become 2 by 1 means 2, which is greater than 1. That means this series is divergent. You can also check it by using ratio test. Okay, so let's do some good example based on this. Okay, suppose let's say my an is x to the power n plus 1 divided by n plus 1 into root n. Okay, so let's say this is my series. My series is summation of an, and here x is any positive number. So I have to find out the value of x for which my series will converge and for which my series will diverge. Okay, so which test I will apply? I will see here this is like x power something. If I use root test, it will be n plus 1 power n. So it will be more difficult for me. So I will use ratio test. So limit n tends to infinity an plus 1 divided by an. This will become limit n tends to infinity x power n plus 2 divided by n plus 2 into root n plus 1 into n plus 1 root n divided by x power n plus 1. See here this will get cancelled out. This will become root n plus 1. It will remain limit n tends to infinity x into root n into n plus 1 by n plus 2. Just put infinity, you will get infinity by infinity form. Apply L'Hopital's rule. What you will get? You will get x. Yes, this term will become 1. So when this series will convergent, if my x is less than 1, my series will be convergent. And when it will be divergent, if x is greater than 1, then it will be divergent. So what will happen if x equal to 1? If x equal to 1, by this ratio test, we can't say anything. Let's put x equal to 1. Suppose my x equal to 1. So what will my an? My an will be 1 by n plus 1 root n. I can't apply ratio test. I said where ratio test and root test are not valid, we have to again go that comparison and limit comparison test. So I am doing by limit comparison test. See here what is the, and see here the denominator power is more, so I have to assume 1 by n for 1 by n power something. What is that something? The power of denominator is 3 by 2. So I am assuming bn is 1 by n to the power 3 by 2. Let's consider limit n tends to infinity an by bn. Do here limit n tends to infinity n power 3 by 2 by n plus 1 into root n, which will come as 1, means which is greater than 0, means this series is convergent by p series test. So this will also converge. That means for x equal to 1, my series is also convergent. So what is the conclusion? For x less than equal to 1, my series is convergent, and for x greater than 1, my series is divergent. Hopefully it is clear. Let's do this type of one example based on root test. Suppose my an is x power 2n divided by 2n power p. Okay, this is my an. My series is summation of an. Okay, so I have to check 2n power p. See here. So which test I will apply? Yes, of course you can also use ratio test, but root test, here its power is 2n. If I use root test, it will become x square. Yes, so I am using root test here. Limit n tends to infinity n power 1 by n power 1 by n. So it will become limit n tends to infinity x power 2n into 1 by n. This will become 2n p into 1 by n. Means limit n tends to infinity, x square divided by 2 power 1 by n into n power 1 by n whole power p. Put infinity here. We know n power 1 by n, it will 1, 2 power 0, 2 power 1 by infinity means 0, 1 power something is 1, 1 power p, it will remain 1, means it will come as x square. So when this series will be convergent, if this is less than 1, if x square is less than 1 or x square is less than 1 means mod x is less than 1, then my series will be convergent. If x square is greater than 1, this value will greater than 1 or mod x is greater than 1, then it is divergent. If it is x square equal to 1 or mod x equal to 1, we can say anything by this root test. So if mod x equal to 1, what will my an? My an will be 1 by 2n power p. Here if you put x square equal to 1, 1 power n, 1 power something will be 1 only. So 1 by 2n power p, it will my an. So we studied about p series test, when it will convergent. If p is greater than 1, then only convergent, and if it is p is less than equal to 1, then it is divergent. Okay, so what is the conclusion? This one, and if x square is equal to 1, then you have to also consider the p. If x square is less than 1, x square or x square greater than 1, it will not depend on value of p, but if x square equal to 1, it will depend on the value of p. It will be convergent or divergent. Hopefully it is clear. So I think this ratio test or root test are clear. Let's go to a last test. So before going to the test, also let's study about a series, another special series, that is called alternating series. Alternating series. This alternating series means, as this name is alternating, means in series every term has alternating sign. Means if one is positive, then next one is negative. Means it will like plus minus plus minus plus minus or minus plus minus plus. Means how can I write? If a1 minus a2 plus a3 minus a4 plus a5 like this, or minus a1 plus a2 minus a3 plus a4. So these are my alternating series form. So in short, how will write? I'll write as summation of minus 1 power n plus 1 n from 1 to infinity, and I will write this as n from 1 to infinity minus 1 power n. So this will be my alternating series. So for testing this type of series, I have a special test that is called Leibnig test. Okay, that is called Leibnig test. What this test says, suppose consider this sequence only an, means the sequence of only positive number, take the modulus. Okay, don't consider this one. Consider this, suppose this series an. Consider this series an. If this series is monotonically decreasing, that means an is greater than equal to an plus 1, as well as limit n tends to infinity an equal to 0. If my an is satisfying these two conditions, then my series minus 1 to the power n or minus 1 to the power n plus 1 an is convergent. I think it is clear. Let's understand by an example. Let's understand by an example. Suppose my series is minus 1 to the power n plus 1 log n by n from 3 to infinity. Okay, so see here, what is my an then? My an is log n by n. So check these two conditions. This is the alternating series. So when I can say my series will converge and divergent, I have only one test, that is called Leibnig test. Apply these two conditions. If it is satisfying these two conditions, then my series will be convergent. So I am checking the first condition because it is a simple one. Limit n tends to infinity an means log n by n. Again apply L'Hopital's rule, it is coming infinity by infinity form, means limit n tends to infinity 1 by n divided by 1. Put infinity, you are getting 0. So second condition satisfied. Let's take the first condition. Means according to the first condition, what should happen? My an should be greater than equal to n plus 1. means my log n by n should be greater than equal to log n plus 1 by n plus 1, or n plus 1 into log n should be greater than n into log n plus 1. We studied a property of logarithm, that is log x to the power m will be m times log x. Yes, so I can write here log of n power n plus 1 is greater than equal to log n plus 1 power n, or n power n plus 1 greater than equal to n plus 1 power n. I need this one. Just check n is starting from 3. So put 3 power 4 is greater than equal to 4 to the 3. Yes, this is correct. 3 power 4 is greater than equal to 4 to the power 3. It is correct. So for all n greater than equal to, it is true for all n greater than equal to 3. So just go from down to top. That means n is greater than n plus 1. This condition is also satisfied. Means this series is satisfying all the two conditions of this Leibnig test. So this series will be convergent. So I hope all the concepts are clear for today's class. We will meet in the next video. Till then, पढ़ाई करते रहिए. All the very best.